So here's 5 definite integrals. And then we're going to talk about U sub. U substitution. So I'm going to give you an example. Example 1. Integral from 2 to 5 of 4 minus 2x. Let's just do this one as a quick reminder of if you remembered anything from integral from Calc 1. So do it and send me your final answers. So see if you remember how to do it. Integral of 4x. Integral of 2x. You add 1 to the power of x. Yeah, is x to power 1. So you're adding 1 to that, it's 2. And you are dividing by that 2. And then you go from 2 to 5. So now I want you to complete. As a recall, remember x to power n dx is you're adding 1 to the power and you're dividing by that constant you added 1 and then plus c. Okay, great job. Great answers are coming through. Thank you. Awesome. Thank you, thank you. So let's do it. So now substituting 5 upper minus lower. So 4 times 5, 20. Minus 5 squared is 25. So that's for the upper. Minus the lower. 4 times 2 is 8. Minus 2 squared is 4. 20 minus 25 is -5 minus 8 minus 4 is 4. So -5, -4, -9. Okay, great. In your work, as you are showing, I want you to show your steps too. Not just saying this is the integral and -9 is the answer. So a couple of steps of showing work, not exactly like I do it, but something that I know you're not just copying the final answer from here and you're working. Okay. So let's do another example. Example 2. Integral from 0 to 2, 2x minus x cubed dx. So now I give you a minute. Of 2x. Great job, everyone. Integral of 2x, you're adding 1 to the power of x, that would be 2. And then you have the 2 here as of the constant, but now you're dividing by 2. Minus, you're adding 1 to the power of x cubed, so it's going to be 4, and dividing by that 4. Going from 0 to 2. 2 and 2 simplifies. 2 squared is 4 minus upper. Still 2 to power 4 is 16. 16 over 4 is 4. That's substituting 2 that is upper into my equation, minus substituting 0 as of the lower into the equation. So the final answer is 0. Awesome job. Let's do another one. This is a bit tricky. Example 3. Integral from -3 to 0 of 1 plus radical 9 minus x squared dx. So for this one, I want to give you a little bit of idea here. So soon, in a couple of sections from now, somewhere in chapter 7, you're going to learn a technique of how to evaluate this integral. For now, I'm going to give you some clue. First, separate these as 2 integrals. So integral of 1 dx, an integral of radical 9 minus x squared dx. And then going from -3, of course, to 0. For 1 is easy. For radical 9 minus x squared, you don't have a u sub. I want you to think of if you were graphing this one. Think about graphing it and think about area under the curve for that. We're going to get to techniques of how to find the integral of radical, something like minus 9 minus x squared. But for now, because we don't know those techniques yet, as a class, we're going to graph this, and we're going to talk about the area under the curve here. So let's see what that is. If I have y, I want to graph y equal to radical 9 minus x squared. Agreed? Y equal to radical 9 minus x squared. I'm going to do it way below, so then it's not interrupting my answer for the integral. So can I square both sides? So y squared is equal to 9 minus x squared, because the square and the square root cancels. Then can I add x squared to both sides? So x squared plus y squared is equal to 9. What is the graph of x squared plus y squared equal to 9?
Circle.
It's a circle. Awesome. So, but then keep in mind that this is not a whole circle, because if you had y squared equal to 9 minus x squared and you were taking a square root, it would have been positive and negative. So if you're only considering the positive radical 9, means we are considering the upper part of the circle. So that's for one thing. And then considering the upper part, but our integral specifically is going from -3 all the way to 0. So we are considering only a quarter of a circle because it's from -3 to 0. So I know it's not this part because I only had the positive here. I didn't have the negative radical or positive and negative of the radical. So I knew it's going to be the upper circle. And specifically for this integral, I'm going from -3 all the way to 0, which is quarter of a circle. Integral is equivalent of area under the curve. Do you all agree with that? integral is the same thing as area under the curve. And for the area under the curve of this pink shaded area, so area of the whole circle is pi r squared. So in this case, pi times 3 times 3, because radius is, so area is pi r squared. So r is 3, so 9 pi. But then you're dealing with just a quarter of a circle. So 9 pi over 4. So the integral of this piece is 9 pi over 4. What is integral of 1? Everyone. Awesome. X. Great. And then it goes from -3 to 0. So it's 0 minus, substituting the lower piece, -3. So this is 3 plus 9 pi over 4. So it's going to be positive 3. Plus 9 pi over 4. Any questions so far? Okay, let's move on to the next. So now let's deal with a little bit of U substitution. I just wanted to recall some indefinite integrals. Now let's just do some U sub. Example, which one? 4. Let's do example 4. Integral of 2x radical 1 plus x squared dx. So one of you were asking me if I can rewrite radical as power of 1/2. In this case, it would help. So I see I had a question on the previous one. So how did I get 9 pi over 4? So what is the area of the whole circle in this case? The area of the whole circle. Pi r squared, what is r? 3. So pi times 3 squared is 9 pi. But you are dealing with only quarter of a circle, so 9 pi over 4. That's how I got it. Did you get that? Great. Yeah, keep asking me questions if you feel that you need more time on things. Okay, now with U sub. So do you see that you have 1 plus x squared on the radical, 2x outside, and dx. So in order to find, so all you know for one of the rules of integral is that if you have x to power n, dx is x to n plus 1 over n plus 1, and then plus a constant c. That's what you know. In this case, it's nothing similar to that one, but you may change it to something that gets similar to that one. What if I let 1 plus x squared to be equal to u? And I'm going to tell you one of the reasons that I love teaching Math 193, because it involves a lot of creativity. So you need to think, you need to say, okay, if that's u, then I have du. So I want you all to write down u as a 1 plus x squared. Why did I let that to be u? Because I knew that derivative of this one is 2x. So basically, now think about what is du. And that's the u substitution method. So I want you all to write what is derivative of u. Derivative of 1. So it's 2x dx. Don't forget to write, so derivative of 1 is 0. Derivative of x squared is 2x. And then, but remember when you are taking derivative of 2x, also consider derivative of inside. Do you remember chain rule? So you are bringing 2 to the back, so it's 2x, but multiplied by derivative of inside x, which is dx. So 2x dx. Now let's look at the beauty here. So 2x dx together is du in this case. So I'm going to rewrite my integral. I'm going to write 2x dx as du. I'm going to write this as radical u. Now, u to 1/2 instead of radical du. So I want you to calculate this one. What is integral of u to power 1/2? And then substitute back u at the end. So let's say a minute. So let's do it together. You're adding 1 to the power of 1/2. What is 1/2 plus, let me change the laser. So you're adding 1 to the power of 1/2. 1 plus 1/2 is equal to, you give denominator of 1, is 3/2. Is it multiplying top and bottom by 2 is 3/2, correct? Then so you would write u to power 3/2, you're adding 1, and you're dividing by 3/2 or multiplying this by 2/3. So basically you added 1 and 1/2, which is 3/2. So that would be the power here. Then by the rule we had, we are dividing by 3/2. But dividing by 3/2 is the same thing if you are multiplying the quantity by 2/3. And of course, plus a constant c. So the final answer, so I don't want things in terms of u, I want things in terms of x. So what was u? 1 plus x squared to power 3/2, everything multiplied by 2/3. Plus constancy. So let's do something fun together. I want you all to take the derivative of this one. If you take the derivative of this one, you should get the original back, right? I want you all to take the derivative. So to check your work, take derivative of 2/3 times this parentheses. So do you know how to find a derivative? You write the constant. What do you do with the power? Do you remember a derivative? You would bring the power to the front. So that would be 2/3 times 3/2 times 1 plus x squared. And you subtract 1 from the power. Once you brought the power down, you subtract 1 from the power. 3/2 minus 1 is 1/2. Multiplied by derivative of inside. What is derivative of inside? Two x. And derivative of constant is 0, so I'm not worried about that. 2 and 2 cancels, 3 and 3 cancels. Looks great. So I have 2x, matching the top one, 2x. And then 1 plus x squared to power 1/2. There you go, and that's radical. So do you see, when we took the derivative of our integral, we got the original back. Agreed? And that's pretty cool, I think. Okay, awesome work, awesome participation. Okay. So I see your responses here. And again, you may ask, like, how do I know it's a U substitution? The more you practice, the more you know if it's a U substitution or not. X cubed cosine of x to power 4 plus 2 dx. So sorry, this is example, in fact, 5. Okay. So I want you to think of what U substitution here. What do you let U to be? Once you figure out what is U, I think it's 75% of the problem done. Exactly. Exactly. So you let x to power 4. Awesome job, everyone. X to power 4 plus 2 to be U. Again, once you figure that out, then it's easy to figure the rest of them out. So you don't let cosine of that thing to be U, because then derivative of cosine is negative sign and you don't have it there. But inside the cosine, you let that to be U. So now I want you to find du. Then I want you to substitute it in the integral. And then I want you to find the answer. So I'm going to give you, let's, a minute or two. Let's do it together. Du is 4x cubed. Don't forget to put dx. So instead of x cubed dx, so for the x cubed dx, I divide both sides by 4. So instead of x cubed dx, because that's what I have here, I replace it by du over 4. And then I have cosine of u, integral of that. Oh, how I got du? Yes. So do you see du means derivative of u, right? You bring the power of 4 to the front of the variable, so that's 4x, and then you subtract 1 from the power, so it's 4x cubed, and derivative of plus 2 is 0, so derivative of constant is 0. So that's why you have 4x cubed. Then I have x cubed dx on my integral, so I isolate x cubed dx by dividing both sides by 4. So instead of x cubed dx, I replace it with du over 4. Make sense? Okay. What is antiderivative of cosine? Or what is integral of cosine? Sine or a negative sign? So think about it as opposite of derivative. What is derivative of cosine? Negative sign. Antiderivative of cosine is positive sign. So sine u, and then you also have this constant. You can always pull constant out. So it's 1/4 sine u plus c. What is u? You need to now substitute it back. So it's 1/4 sine x to power 4 plus 2. Maybe another lesson to take from now. Integral of cosine u du is equal to positive sine u. Or integral of cosine x dx is sine x. Of course, plus c. Okay. Any questions? So I'm going to write down the next example until if you have questions, still type in the chat. Here is the next question. Integral of 1 to 2 of dx over 3 minus 5x to power 2. So think of what is the u substitution here. What should you let u to be? This is a definite integral. So that means either you reevaluate the limits by u or completely solve it. And then once you found with x, you replace it. So let's just solve it first. So do a u substitution here. What should u be? So write this down. Excellent. Excellent. So what should be very good? So u must be 3 minus 5x. How do I know that's u? Because I know that du is just something with dx, and I have that on top. So I want you to find du. And calculate it, send me your final answers. I want to know how you would think of this one, how you would process it. There are two ways to calculate the definite integrals here. We're going to talk about both, but I'm going to see how you do it first. Okay. Yes, derivative of 3 is 0. Derivative of negative 5x is just negative 5 because you bring the power of 1 to the front is negative 5 times 1, negative 5, and you subtract 1 from the power. 1 minus 1 is 0, x to 0 is 1. So negative 5 dx. Okay. So I want you to go on, substitute dx with its equivalent. Substitute 3 minus 5x with the equivalent and see if you can evaluate the integral. So you may recalculate the bounds, like the lower bound and upper bound. Or you may find the final answer and substitute it back. Let me just recalculate the bounds in this case. So first, let's substitute. So in the denominator, I have u squared. In the numerator, instead of dx, because I have dx, instead of dx, I will put du over negative 5, which I can pull that negative 5 out. Do you agree? So I can go on here, find the integral, substitute u back, and then calculate the limits, or recalculating the bounds. So when x is 1, what is u? 3 minus 5 times 1. So that is 3 minus 5 is negative 2. And then when x is 2, replacing it by 2, 3 minus 10, I think is negative 7. So in this case, you can just go with the limits that you see here. Okay, so let's do that. Negative 1/5. What is integral of 1 over u squared? Integral of 1 over u squared. Do you agree that's the same thing as u to power negative 2? So basically, you could have rewrite this integral as negative 2 to negative 7, u to power negative 2 du. If that makes sense. So then you would add 1 to the power, so that's negative 1/5. Adding 1 to the power, so that's u to power negative 1 over negative 1, and then going from negative 2 to negative 7. So basically negative 1 or negative and negative cancels each other. So if I'm rewriting this one is like 1 over 5 u, because u to negative 1 is like so now you go from negative 2 to negative 7. It doesn't matter if the lower bound is smaller than the upper bound, or it doesn't matter. So if you flip them, then you have to have a negative outside for it. So I wouldn't flip the bounds. I just put it as I see. For 1, equivalent is negative 2. For 2, equivalent is negative 7. Make sense? If you want to flip them, then you have to put a negative outside, which is unnecessary. Okay, not that is wrong, but you need to make sure that you put a negative outside. If you put 1, no, it's going to be negative 2. If you replace x by 1, 3 minus 5 is -2. Okay, so that's 1 over replacing the upper. The upper doesn't mean the greater, so whatever is the upper bound. 1 over -35 minus 1 over -10, which that turns into a plus. So 350, I mean, whatever way you want to come up with the common denominator. Or if you can, let's just think of something smaller, 70. 70 to be the common denominator. Top and bottom of the first one by 2. So it's -2. Top and bottom of the second one with 7. Is that +5 over 70, which you can simplify here. 70 divided by 5, I think is 14. Yes, so 1 over 14 is the final answer. So we recalculated the bounds. Or again, you could have ignored the bound until the end. And then once you substitute x back, you calculate with 1 and 2. But after you substitute it back. In this case, do you see we didn't substitute u back because we recalculated the bounds? Does that make sense? Let's say if I was not doing it with recalculating. So then, once you had 1 to 2, dx 3 minus 5x to power 2, you would ignore these two until the end. Let's say you got to the point where after u substitution, you got to u to power -1 over +5. You would have replaced that by 3 minus 5x. So this is the same thing as 1/5 over u. And that was 1 over, our u was 3 minus 5x. Then I would use the actual 1 to 2 limit because I substituted u back. So then in that case, I would have had 1 over 5 times 3 minus 5x, replacing 2, 3 minus, if this was 2 here, -10, -7, minus 1 over 5 times -2, 1 over -35 plus 1 over 10, exactly what we had here. And we calculated and we got to 1 over 14. So you could have recalculated u, or you could have substituted u back and used the original limits. That's what I want to tell you here. So let's go to the formal definition of u substitution. So I'm going to share my screen with you for the formal definition. So the substitution rule, formal definition. So I want you to see the formal definition here. If you have an indefinite integral, as what you see here, f of g of x times g prime dx. you let g of x to be u, then du is g prime. So instead of calculating the big integral, you calculate integral of f of u du. So u must be differentiable function whose range is on interval I, and f to be continuous on I. So that's the formal definition, if you want to copy it. Any questions? Okay. So not that I will ask you for formal definition, but I want you to know where these are coming from. I will give you actual problems on the test, like the examples we did, and ask you to do that. Okay, so for home, tonight, I will write down 2 examples. I want you to do them. I want you to do the integral integral of x to power 5 square root of 1 plus x squared dx. You can always refer to the notes and compare your answers. It's on the notes of 5.5. And also integral of tan x dx. Keep in mind, tan is sine over cosine. So think about how you would do that. So do a u substitution there. So these are the 2 examples I want you to do today. Today is the first day. So I'm not going to give you a lot of homework. So I want you to enroll, do these 2 along with the notes, and then send them to me before 11:59 p.m. tonight. The assignment is already up. Oh, I want you to start the homework of 5.5 too. So you have 3 homework due on Wednesday. But if you put all of them for Wednesday, Wednesday itself would be filled with notes and after class work. So finish these 2, send me everything we did together as one file of PDF, submit it under that assignment that I put up for today's date, which was 6/12, and then get us started on 5.5 homework. Is that clear?